This is predominantly a structure determination question with a little bit of polymers thrown in. Going to see a lot in here about NMR. 4 sections, A to D. Try them, pausing as you go, and then review with the remainder of the video. So here's A, B, C, and D. Okay, several isomers with the molecular formula C6H16N2, and we've got one of them provided here. We want to know how many different peaks there are in the carbon-13 NMR spectrum. Now, what you're looking for here are carbons that exist in a different environment. And we can see here there are some that have the same environment as each other, but there are differences as well. And I've colour coded them so we can see. Because I've got 2 ethyl groups coming off the same N, I know that they have got identical environments. My yellows are the CH2s next to the N, and my blues are the CH3s on the end of the ethyl chain. But on the other side, I don't have the symmetry. My pink and green, it's not an ethyl group because there is an amine group NH2 at the end. So in total, I've got 4 peaks. The next question is about the splitting pattern of the hydrogen or the hydrogens labelled A. So to work out the splitting pattern, you've got to look for the number of neighbouring non-equivalent hydrogens. So it's a triplet, because if I look to the left, I have an N that has no hydrogens, and then on the right, I've got 2 hydrogens, and they are non-equivalent because they're in a different environment. Now the splitting pattern follows the N+1 rule. 2 neighbouring non-equivalents plus 1 takes us to the answer 3. Moving on to part B, we need to know the structure of the isomer of C6H16N2 used to make nylon 6,6. Straightforward factual recall, you need to know that it's 1,6-diaminohexane. You could also draw it in this way as well. Moving on to part C, draw the structure of the isomer that contains 2 primary amine groups and has only 2 peaks in its carbon-13 NMR spectra. 2 peaks is making us think symmetry. So I'm going to start it off. I know that by building in this structure, I've so far only got 1 environment. Each C is in an identical position. It's next to a CNH2. I've got to find a way of putting 4 more carbons in exactly the same environment as each other, but different to this. Well, I can put a methyl group in every available position, and I've got to the answer. Finally, part D, I want 2 tertiary amine groups, but still only 2 peaks, so I'm looking for symmetry again. Now tertiary means the N has got to have 3 alkyl groups coming from it, so it makes sense to start with this position. I've got my C's in the middle, but now I need to add 4 more carbons. Well, again, I follow the principle of symmetry, and I can put 4 CH3s coming off. Both of my N's have got 3 alkyl groups around them, hence tertiary amines, and I've got 2 different environments of carbons, and therefore 2 peaks.